All right, thank you all for coming. My talk today is going to be, it's called Goodbye, Hello World, Hello Real World, Practical Guidance for Eclipse Scripting in the Clinic. Uh, my name is Carlos Anderson. I'm a senior software developer or senior software engineer at Radformation. Just to give you a little background about myself, I've been with Radformation for almost 2 years now. I'm mostly working on the Clear Calc product. Before that, I worked at Michigan Medicine for 5 years in the Department of Radiation Oncology. That's actually where I started with Eclipse scripting. Now I do have a PhD, but it's not in medical physics. It's actually in evolutionary biology. But midway through, I decided that academia is not really for me, so I'd rather be programming. So fortunately for me, I did have a background in computer science, and this is where I'm at now. I've also written a few blog posts on programming, including about ESAPI on my website. That's at carlosjanderson.com, and I'll actually have a link in a later slide. And before I start, I do want to mention some things happening today and tomorrow. So don't miss our bingo game night. We're having that tonight at 6. It's going to be a lot of fun, so please join us for that. Tomorrow, we're also going to have a couple of easy fluent presentations, one in the morning at 9 a.m. And we're also going to have a hands-on workshop at 1 p.m. So please don't miss that. I also want to point out that for this webinar, we're offering CAMPEP and MDCB credits. We're also willing to provide MDCB certificates. So please complete the evaluation form by July 30th. A link to that evaluation form is in the handout section of the GoToWebinar. There's going to be a little link there, a PDF link. You're also going to receive a recording of this presentation and a link to the evaluation form by email. All right, in terms of questions, please feel free to submit your questions in that question section of the GoToWebinar. You can ask them anytime you want. Then at the end of the webinar, Tyler's going to go ahead and moderate your questions. So Tyler is here to help me out with this webinar. All right, now before I actually start the talk, I do want to warn you a little bit that I'm assuming you have some experience working with ESAPI. Again, that's the Eclipse Scripting API. Perhaps you've written some scripts, or at least you've attended some introductory courses on the Eclipse Scripting API. If you haven't, and if you're brand new to Eclipse scripting or even programming in general, this webinar is going to feel a little bit like this, just because it's a bit advanced. But that's okay. I think you'll still gain something out of it. But then I'd strongly recommend that you check out some introductory resources for learning ESAPI. Things like the Variant Developer website. There's a lot of example code in there that you can get and learn from. Variant also has a ton of webinars, introductory webinars for learning the Eclipse Scripting API. There's also the ESAPI subreddit. This is something that Matt Schmidt started, and there's a lot of people there eager to answer your questions, so feel free to post things there. And also, I suggest going to my blog. This is my website, carlosjanderson.com. I write a lot of beginner and advanced topics around ESAPI. So you can learn that, and then you can come back to this talk when you're ready. It's going to be recorded, so you'll be able to access it afterwards. All right, so let's actually start with the talk. So here are the 4 main topics that I want to talk about today. We're going to talking about managing assemblies with ESAPI, wrapping the API itself so that your scripts can be more flexible. Then I'll talk quickly about the MVVM architecture so that you can have a nice architecture to your scripts. And I'll also talk about how to implement an undo, redo functionality using the command processor pattern. And finally, I want to talk about some third-party libraries that I think you'll be interested in, because you don't always want to reinvent the wheel. There's been a lot of work out there in terms of PDF generation and plotting and so on. So I'll give a brief overview of some of those interesting libraries. All right, so let's start with managing assemblies. And so one of the first things I want to talk about is what is an assembly, for those of you who are not familiar with. So an assembly is basically a DLL file. This is what contains your compiled code. For example, when you're writing a binary plugin script that you can launch from Eclipse, you're actually compiling it into a DLL file or an assembly. You may have noticed that when you write your plugin script, you actually can't directly run it or debug it from Visual Studio. In other words, you can't just press the start button in Visual Studio and have your script run. This is unlike, other normal programs, standalone programs, where you can just run them directly from Visual Studio. Well, you can't do that with a plugin because it has to be run through Eclipse. You have to launch your plugin from Eclipse every time you want to test it. It's also not easy to debug your scripts because since you're not in Visual Studio, you can't go through your code line by line or let Visual Studio pause whenever there's an exception in your program, for example. Now, actually, you can do it if you attach a debugger after you've launched your script from Eclipse, but it's still a pain because, as I said, you still need to launch Eclipse manually every time. You may have also noticed that you can't rebuild your script once it's been loaded by Eclipse. So if you run your script in Eclipse and then you find a bug or you want to add a feature and you go back to Visual Studio and you make a change, you save your code and you try to rebuild it, you're going to get an error like this, unable to copy the file, process can't access the file because it's being used by another process. So what's happening is that Eclipse is locking that DLL file that you're running and you can't write over it, right? So again, just to kind of describe exactly what's going on there, the reason is this problem is happening is because assembly, so this DLL file, can't be unloaded from what's called an app domain. So let me explain that a little bit better. So you have your what's called a process. This is like an application. This is Eclipse. Inside of that process, you have something in the .NET framework called an application domain. I don't want to describe too much in detail what this is, but basically it's like a container where all your assemblies go in. So for example, Eclipse may load the system assembly. This is something that all .NET framework applications require. But then when you load your script through Eclipse, Eclipse is going to load that script. For example, myscript.esapi.dll. It's also going to load any other dependent assemblies. Let's say you're using a logging package nlog. It's also going to load all that. Well, the problem is that once Eclipse loads everything into this application domain, it's actually impossible to unload it. The only way to do that is to completely exit out of Eclipse and restart it. And this is why you have to do that whenever you want to test a new version of your script. Now, there's a solution to all these issues. One is to use a plugin runner to load and run your script. So what is a plugin runner? It's basically a standalone application that you write in Visual Studio, and because the standalone application is not a plugin, you can actually start that from Visual Studio. You can just hit the start button and run it from there. This standalone application creates an instance of Eclipse. This is something that's typically done through the API. And because it's got Eclipse loaded, you can then manually load your script through the standalone, and the script now has access to the functionality of the Eclipse scripting API. So this is basically bypassing having to open a whole application of Eclipse and doing it yourself through the standalone way of running the API. So here's a sample plugin runner of what might look like if you want to get into it and develop your own plugin runner. Because it's a standalone application, you don't have the patient context. You'd have to have somewhere where the user can enter the patient ID, open that patient ID, look at a list of plans and plan sums that are available, select those that you are interested in, maybe select the active plan, and then run your script. And this is what would actually kick off your script, again, all from Visual Studio. Now I've written an easy-to-use plugin runner in my ESAPI Essentials class library. This is a library I wrote a few years ago that's available on GitHub. You can access it through my website. And it's pretty easy to use because basically the only thing you need to do is just a couple of things. One is when you create your script class, you derive from script base, and then you implement this run method. This run method is going to take a plugin script context. This plugin script context looks exactly like the regular ESAPI script context. It's going to have exactly the same things. And so you can write your code in here just as you normally would. The other thing you need to do is to actually kick things off for the standalone is in that standalone project, and this would be a WPF project, you just need to call this one line, script runner.run, and then instantiate your script, which is this class. So with these two set in place, and when you run it, you'll get, when you run it from Visual Studio, you'll get something like that plugin runner that I showed you a little bit ago. And because of that, you'll be able to step through your code. You'll be able to run it directly from Visual Studio. You'll never have to open up Eclipse again. Another thing I want to mention that you may have also run into are some versioning conflicts. Okay, so let's say that your clinic you're running Eclipse, you guys have a script, called script, you have version 1.0 running, and later on you go ahead and you update that script, and now you have version 2 of your script. Okay, so you tell people in your clinic, hey, version 2 is ready, I want everybody to start using it. One problem is that for those people who are already running version 1.0 right now and they try to now run version 2.0, it's actually not going to work. They're not going to be able to load that script to, because once Eclipse loads that script version 1.0, any other script with the same name, with the same assembly name, and your script, even if it's a different version, is going to have the same assembly name, is not going to recognize it because it thinks it's already been loaded. So it doesn't matter there's a different version, just because it shares the same name, it's not going to really register it. This, as a corollary, any assemblies that your script depends on could also run into the same issue. So for example, here's a Eclipse, you have a script called my script. Let's say you have a different script called your script. Okay, so they have different names, so they can both be loaded side by side by Eclipse. However, one script, my script, depends on nlog version 10.0, but your script depends on nlog 12.0. So again, these share the same name, nlog and nlog. So what happens is when Eclipse first loads nlog 10.0, and now you're trying to load 12.0, it's going to be like, oh, I already have something called nlog, so I'm just going to use the one that's already loaded, and that's going to be nlog 10.0. So what could happen here is that if you use some feature of nlog in 12.0, some method that perhaps doesn't even exist in 10.0, your script is going to crash. So that's going to be a problem. So the way to solve this specific issue is by uniquely naming your script assemblies and your dependencies as well. So in other words, if you have your script and you have a dependency here, you want to rename them, for example, to uniquely. An easy way to do that is to include the version number in there. So script 1.0 and nlog 10.0, so that you can have multiple versions loaded side by side. It's not too bad. It's kind of straightforward when you're dealing with your own script, because you have, your code of your script. So you can go into Visual Studio, you can go to project properties and rename the assembly there pretty easily. The problem comes when you're dealing with these dependencies. Typically, you're not going to have the code available for those. Unless if it's an open source project, you can always download the entire source, open it up in Visual Studio, change the assembly name there, and then rebuild. But oftentimes that can be a pain, because sometimes the build process of some of these open source projects is really complex. There is another way. It's a little more difficult, but it's using something called CSIL. So CSIL is a library that allows you to inspect, modify, and create .NET programs and libraries, right? So this includes .NET assemblies. So this library allows you, through code, to actually open up a DLL, change the assembly name, resave it, and use it as normal. So I've done this with several libraries here at Radformation, where I didn't want to rebuild it myself, so I just used CSIL to open up that DLL and rename it. Now, let me point out that it's not good enough to just rename the file. You can't just, rename the file .dll to something else. You have to go in there and change the assembly name itself, which is a little more complex than just renaming the file. This is why you would need something like CSIL to do that. Here's another tip with dealing with assemblies. It's totally optional, but this is something that we do at Radformation. You probably notice that if you are using a lot of third-party libraries and even referencing different projects within your own solution, you're going to get a bunch of output files. This is just an example of our ClearCalc administration program. We get a bunch of DLLs and other output files, and this becomes a little messy sometimes to kind of give to the end user. It's just a lot of files to deal with. So what we do is we use something called FODI, actually FODI Costura, to package all these DLLs into one single application. And so this is much easier to manage in the file system. There's another program called IL Merge that I've also had success with. So if you want to check out into this, I recommend looking at both of those options for that. All right, let's move on to wrapping ESAPI and what this means. So typically when you're writing your script, you're going to use ESAPI directly. I'm going to point out why this has some disadvantages, but here's some sample code of using ESAPI directly. Here's your ESAPI application. There's a variable called app. You can open a patient. You're looking through courses, looking through plan setups, trying to find the course and plan that you're interested in. You might access properties from that plan. Let's say the number of fractions, you're getting the dose per fractions. You're then summarizing that as some kind of prescription summary that you're returning to the user. So all this looks pretty great. You're using ESAPI there, but there are some disadvantages of using ESAPI directly like this. For one, ESAPI objects are kind of heavy, and they obviously depend on Eclipse being there. So if this is your script and you're accessing ESAPI, ESAPI is actually a C# layer on top of a C++ layer of Eclipse. So ESAPI has to go through and talk to this Eclipse layer, which then may need to talk to the ARIA database to bring up whatever data you've requested. And then it has to make its way all the way back to your script. In some cases, this could be really fast and instantaneous. In other cases, it could take a few seconds to actually load everything. So this could be a bit slow sometimes. Now, this just kind of has to happen because that's the way Eclipse works. But one disadvantage of this, of accessing ESAPI directly like this, is that you need to have, of course, Eclipse installed on the computer where you want to run your script. If you're trying to develop your script on your own personal laptop, for example, that doesn't have Eclipse installed, or you're doing it somewhere else, you're not going to be able to. You're going to have to be on a computer that has Eclipse installed. This could be sometimes a bit inconvenient when you're just trying to develop a quick script to do something. So that's one disadvantage. Another one is that it makes your scripts kind of inflexible in terms of the kind of data source that you want to use. So if this is your script and is using ESAPI, it's going to be getting the data source from Eclipse. But let's say that later on, like we do at Radformation, you want to start using sources from DICOM files, where your script won't be able to do that out of the box. Or let's say you want to hard code some test data because you want to be able to have some automated test runs of different patient values and plan values. Your script is not going to be able to do that because you're basically tied to Eclipse directly. So one way to solve this is to write what I'm calling here a TPS service interface. So you're writing a C# interface that your script is going to use, but it's not going to reference ESAPI directly. So if this is your script, it's going to reference an interface. And just to reiterate what a interface is in C#, an interface is basically, it looks like a class. I actually have an example here. It looks like a class, but it doesn't have any code. It just has declarations, basically just has types. For example, here I have a patient and a plan, both of which are types, patient and plan, that you write. These are not going to be part of the API, of the Eclipse scripting API. These are things that you write yourself, and your interface is going to be returning these things. But notice that there's no implementation here, it's just getters. If you had methods, the methods would actually be completely empty. So the script, your script actually would have no dependencies to any specific code. Now you might think, well, this is useless. Well, not quite, because you'll have separate projects that will implement that interface using, for example, the various libraries that it might need. So if you have this ESAPI service where you want to obtain information from Eclipse, you'll use ESAPI directly only in this class and in this project. You may have a different service called a DICOM service that implements this interface, and it might use, let's say, something like Evil DICOM to load DICOM files and the DICOM patient and plan data for your script to use. Or you may have another implementation that simply uses test data. You can either hard code that data into the class itself, or you might load it from a file, for example, if you're doing some kind of automated tests. And I'll show examples of how to implement some of these services. So here's an example of what your script might look like. Your script that's now using this interface. It's not using ESAPI directly, it's actually using the interface. So it takes this interface through its constructor, it saves it, and then later on where you call start for your script to begin, let's say it creates a new window, it's going to initialize itself. Here's accessing this patient and the plan from your interface. So it's going to send it to your window for it to process and then show that window. So in this case, for example, it might be something very simple like this, patient plan and then the prescription summary. So this data may come from different sources, and I'll show next how that could happen. Actually, let me quickly just briefly go through what your interface may look like, right? So I showed you this interface, this ITPS service. It just has a patient and a plan. Again, you write what that patient is going to look like. The patient, you might only be interested in the ID, the last name, and the first name. And for the plan, you only might be interested, again, in a subset of things. So this brings me up to an issue where you don't really need to implement all of the API. It's very big, right? You might only need a subset for your specific script. So you don't need to have everything that the API, that the Eclipse scripting API provides. You might only want to have a subset of that. So let's look at the implementation one. This is the ESAPI service, okay? So you might need a login method to actually create. If you're using a standalone application, you might want to create that application here. You might want to have a logout to dispose of that application. The important thing here is that you need to have this patient and the plan, because those are things that are defined by the interface. Notice here that in this implementation, I actually do have the ESAPI app, the ESAPI patient, and the ESAPI plan, things that are going to be loaded on the next slide here. So for instance, I have my open patient method where I take in the patient ID. Here, I am using the ESAPI application to find that patient, save it in my class, and then assign my patient property to values contained in that patient. So this new patient is actually one that I own that class, and I'm initializing it with the patient from ESAPI. In this case, it's very straightforward. It's just basically copying these properties, the ID, first name, and last name. I do a similar thing when I want to open a plan, given a course and a plan, course ID and a plan ID. I find that plan, and then here I also create my own plan, initialized with properties coming from the API. ID is pretty straightforward. Notice that fractions, I do have to do a little bit more. I have to find that number of fractions and get the value or default, just because this number of fractions is actually a nullable type. And I also pull the dose per fraction dose out of that to store it in my simple type dose per fraction of type double, right? So notice that not everything has to be one-to-one. Sometimes you can actually simplify the API to adapt it to your own classes. And then you'll have a separate project. This is going to be the project that actually starts the application. And so in this app startup method, here's where I create my ESAPI service. I log in, I open the patient and open the plan that I'm interested in, and then I create my script. And then to that, I send in the ESAPI service. Now, again, this script does not depend on ESAPI service directly. It depends on the interface. But the nice thing about C# is that you can send an implementation. You can send an implementation, but the script only knows about it from its interface. And then you can start your script. Here's an implementation 2 of the interface called test service. So in this case, instead of using the API, I'm just hard coding the values here. So this is going to be used for testing basically. I hard code a patient, I hard code a plan, and then in my actual application that kicks off this this test service, I create the test service and pass it to the script. So notice that in the couple of slides ago, I was passing an ESAPI service. Now I'm passing a test service, and it works perfectly fine because as long as they both implement the interface, I can pass in those classes to my script. And so again, the beauty of this is that your script doesn't need to know where the data comes from. It could come from ESAPI, it can come from DICOM, it could come from test data, but it's still going to work the same way. You don't have to change your script whenever you're changing data sources. Just to kind of reiterate this whole message, here I have what's called a project dependency diagram for this example, just to kind of show you which projects depend on what. So here my script project, this is like your main script, right? It only depends on this TPS service project. This project just contains the interface and that patient and plan classes that you write. It does not depend on anything else. It just has that interface that your script depends on. But those applications, the ESAPI start and test start applications, those are the ones that are going to kick off the actual application. Those do depend on the ESAPI service in the case of the ESAPI start, and in the case of the test start application, depends on the test data project that implements this interface of TPS service. So notice that this one does depend on those services and on your script because it has to pass the implementation to your script. Same thing with the test projects. But the main point here is that your script project only depends on that interface, not on anything else. Another benefit of having wrappers is that wrappers around the API is that you can handle multiple versions of ESAPI. So far I've also been talking about having an interface. You have this ESAPI service that implements this interface, and this ESAPI service can go ahead and reference ESAPI. But there are multiple ESAPI versions, as you know. You can have ESAPI, for example, 13.6, ESAPI 15.5, ESAPI 16.1, and so on. So by wrapping the API, you can also handle these multiple versions without having to modify your script because you're handling those versions downstream by the ESAPI service, not by the script itself. So you can have multiple versions as they come in, handle them appropriately, and your script doesn't have to change. Sometimes you might need to change something a little bit to handle a new functionality and so on, but generally it won't need to change. And I'll show how you can handle these multiple versions. So step one is to actually create build configurations for each ESAPI version. So what's a build configuration? This is a set of options for building your Visual Studio solution and its projects. You can have more than one configuration to set different options for those configurations. So what we want to do here is we want to create one build configuration for ESAPI 13.6 and another build configuration for ESAPI 15.5. I'm just showing an example here of two versions. When you go to right-click on your project and you go to, when you go to the configuration manager through Visual Studio, here you can create a configuration. For example, I'm naming this one debug 13.6 and here too, because these are the two projects that depend on the API. But for this build configuration 15.5, I'm naming them debug 15.5 and debug 55. So now I have two named build configurations. Step number two is to reference the correct ESAPI version for each of those configurations. Now, unfortunately, you can't easily do this through Visual Studio. You actually have to open your project file. This kind of tells you it's actually kind of an advanced topic, but you have to open your project file. And in there, you have to add these lines of code. You have to say, you know, if my configuration is debug 13.6, go ahead and reference ESAPI 13.6. But if my build configuration is 15.5, I want to reference ESAPI 15.5. So depending on which configuration you're on, Visual Studio is going to figure out which ESAPI it's dealing with. Step number 3 to this is to define compilation symbols for each configuration. So if you've never used a compilation symbol before, it's basically like telling a specific configuration that a certain constant value exists. Right? It's kind of like a presence absence thing. So for our configuration 13.6, I'm defining this constant ESAPI 136, and for my configuration 15.5, I'm defining this constant ESAPI 155. And by the way, to get to this view, you have to right-click on projects, go to properties, right-click on your project, sorry, go to properties and go to this build tab, and you'll have access to these compilation symbols. So how do you actually use these symbols, or what are they for? That's in our step 4. Okay, so if you remember this method that I had before to open a plan that actually depends on ESAPI, here we can use our compilation symbols because actually the way you get the fractions and the dose per fraction is different in version 13.6 and version 15.5. So you use the conditional compilation here. You can say $if I'm in ESAPI configuration 13.6, go ahead and get the fractions and the dose per fractions this way. You have to get this unique fractionation, number of fractions, and then get the value. Similar thing with the prescribed dose per fraction. But if I'm on configuration 15.5, I can go ahead and do it this other way. Directly access the number of fractions and directly access the dose per fraction. So because, again, the beauty of this is because it's happening downstream, your script itself doesn't have to change at all. Your script still accesses the plan's fractions or dose per fraction. How it was obtained, that happens inside of our ESAPI service, and you can determine which configuration it's on by simply choosing which one you want to compile at that time. All right, one last thing, nice thing about having wrapping, ESAPI and not using it directly is that you can actually make asynchronous calls to ESAPI. Now, asynchronous calls is nice because that prevents your UI from freezing when you're trying to do some kind of complex operation. So if you're calling ESAPI to do lots of, let's say, dose lookups or dose profiles or something, and it's taking a little bit of time, that may freeze your UI. Well, to avoid that, you can actually start adding asynchronous methods to your interface that will then get implemented by the ESAPI service. So here I have an example where we just have a method that, just get me the dose at this location, give it an X, Y, and a Z. To make it asynchronous, you want to return a task with a double in it. Now, if you are not familiar with the synchrony, just don't worry about the section. You can check it out later. I do have a blog post about this actually. And in the actual implementation here, what you want to do is you want to start a new task, and then inside of that task is where you actually call the ESAPI method, get dose to point, to actually process that, request and return it. And so this, when you call get dose gray, you'll want to use the async await pattern to be able to, free up your message loop so that the UI is freed up and doesn't freeze while it's actually fetching this information. One thing to note that is that because ESAPI has to run everything on a single thread, and that thread is special, it has to be what's called a single threaded apartment thread, you do need to have this optional line here where you have to send in an STA task scheduler. I don't want to talk about this right here, but this is something that I do describe in a blog post. All right, so we've seen all the benefits of not calling ESAPI directly and having your own interface for that. All right, the next thing I want to talk about is the MVVM architecture and how that can help you develop clean and structured scripts. Now, MVVM itself is a pretty large topic. There's entire books on it. So I'm just gonna quickly have an overview, like, in less than 5 minutes, kind of discuss like the gist of it. because otherwise it will take, forever. Hopefully you're somewhat familiar with it. So MVVM stands for model, view, and view model. And it's a pattern, and it's all about separation of concern. So what I mean by that is having different aspects of code do different things. You don't want to have one single file or one single class that does everything, that uses UI, does a logic, does reading and writing of data. It becomes a big ball of mud. It becomes difficult to maintain, difficult to understand, and it can be prone to bugs. By separating things in different classes or different modules, it's easy to understand your code because each piece or each module deals with only one thing. So in MVVM, one of these modules is the view. This is what's actually being shown to the user. And basically use a UI framework to work with it, something like WPF in Windows. The view gets its data to display from the view model. This is a separate class. The view model contains the data to be shown, and it also listens to any commands from the view. Any commands means anything that the user wants to do is going to send that request to the view model for the view model to process. And finally, there's the model. The model is actually your core domain, your core classes, and the functionality that your script actually does. This is where most of your code should be, in this sort of realm of the model. When the model is changed, because in response to some function you do, that model's got to notify the view model that, hey, something has happened here inside of the model, update yourself. And the view model is going to go ahead and get values from that model and update itself, prepare its data to be shown to the view. And then once it prepares that data, it's going to notify the view to say, hey, I'm ready to display this information. And the view is going to go ahead and put that information on the screen for the user to see. All right, so this is kind of like the 2-minute overview of MVVM. But let me go into a little more detail about how the view and the view model can communicate. And the way they do that is through something called data binding. So here's some code of what the view may look like in XAML. XAML is a language for how you can implement UIs in WPF. You don't have to understand this in detail, but just kind of get the general idea of it. So here, this items control, I'm basically defining a list of things. And this list, the source of that list is coming from this property called patients, and I'm binding to my view model right here. So if this is my view model, let's say called main view model, and I have this patients, these names have to match so that the view knows that it's going to get the information from this patients in my view model. Notice that this type of patients is a collection of patients, and it's actually an observable collection, meaning that when something is added or removed, that's going to automatically notify my view, and the view is going to be able to add or remove view components simply by listening to changes to this patient. Now, for each of those items, I want to display, for each of these patients, I want to display the patient's first name and last name. So again, I use binding so that in my view model, I have to have these properties that match. And these are not simple get set properties. I do have to have a little bit of code here, some helper code, in order to notify my view that things have changed. So what I'm using here, I'm using this view model base abstract class that's coming from a package that I'm using called MVVM Lite. This helps a lot with you not having to write a lot of this boilerplate code. So once you inherit from this base class, you can actually call something as simple as a set method. And what this will do, this set method, will actually change the value of your first name member variable here, and it will notify the view that something has changed. So this all happens within the setter method. All right, also views, like I mentioned, can send commands to the view model. So something like a button, let's say a user presses a button, you can use binding to tell the view model that this is the command that needs to be executed when the user presses this button. So here I have a add patient command. Don't worry so much about this. This is another helper class from that MVVM Lite package. Basically, here's the code for that command. When the user presses the add patient, this is what's going to be run. We create a patient model. We create a patient view model. We initialize that patient view model with the model, and then we add that patient view model to our list of patients. When this is added, it's going to be added to this list and is going to, again, notify the view that it needs to update its view. So here's an example of a patient view model. Like I mentioned before, it contains all these properties that I want to show to the user. So I have a string first name, a string last name, and a string birth date. Now, one thing I like to do for view models is I like to keep everything as strings. This keeps things as simple as possible, because this is exactly what I want to display to the view. Now, in the model, you're going to see that this birth date is actually a date time, but in the view model, I just want it to be a string. This gives me full control of what I want to display. Let's look at how that view model is initialized from the model. So we have my initialize method. It's taking in this patient model. It saves it because it's going to use it for later. And then I call these three methods: update first name, update last name, update birth date. So if you look at the definition of those methods, all it's doing is saying, my first name property is just that patient first name. My last name property is that patient last name. And my birth date, notice here that I'm using some C# code to convert my birth date, date time, into a string. And that's how it's going to save it. And then the next thing it does here in this initialize method, it starts, this is a way to tell it to listen to my model changes. So whenever a property in the model changes, it's going to throw this, raise this property changed event. When that happens, I want to run this method. So what does this method say? It basically says that if my first name changed, go ahead and update the first name. If my last name changed, update my last name. And if my birth date changed, update my birth date. So basically, this is the core of that view model. It's basically initializing itself and then responding to changes to the model. So I have some tips on, and I've kind of mentioned this before, but here's some tips on implementing view models. You want your view model to deal with view-related logic only. In other words, you don't want your view model to read or write data. You don't want to perform any domain logic. This means no performing calculations, not performing any kind of decisions that deal with the functionality of your script. You want all that to be in the model, not the view model. Like I mentioned, I like my view models to be properties to be very simple, things like just strings or maybe booleans. Again, the reason why I want them to be strings is because I have full control of what's going to be displayed eventually in the UI. Sometimes, you might have a property that could be null, and you might want to show a specific string for null. You might want to show a dash or an NA or something. By having strings, you have direct control of what you want to show to the user. Also, you don't want your view model to contain any code for what the command actually does. You want your view model to just focus on formatting data for the view. And I'll actually talk about how you can actually put code in different classes for each of your different commands. And I recommend using a toolkit, something like MVVM Lite, as I mentioned, to make the implementation of the MVVM architecture easier. It just eliminates a lot of the boilerplate code related to notifications and all that. Then I also just quickly want to mention what the model might look like. So here's my model, patient model. It derives from observable objects. This is, again, something from MVVM Lite that gives me access to this setter method. With this setter method in each of these properties, whenever it changes, it sends out a property changed event that then listeners can use to then update themselves. For example, view models can do this. Notice here in this patient, my birth date is a date time. So in the model, I do want to use the correct types because I may use it for calculations. I may have a double for something else, or an integer for age, for example, for my patient age or whatever. I do want to use the real types for those. It's only in the view model that I convert them to strings because that's what I want to show the user. All right, so moving on from that, quick overview of the MVVM architecture, let's talk about undo redo. This is something that oftentimes you do want to have in your scripts because it allows the user to, undo perhaps a destructive operation, or accidentally they might do something, they want to undo that. There's a nice thing to have for usability of your scripts. We want to use something called a command processor pattern, and I'll describe that in a little bit. But basically, when you have your view and it sends a command to the view model, rather than having the view model basically execute that command right in the view model, you're going to offload that execution to a separate class called, let's say, a command processor. This command processor is going to take care of not just executing the command, but it's also going to be responsible for keeping track of whether that's going to be in an undo stack or the redo stack. Now you're going to be using this stacks later on to know, to be able to undo these commands as they are being executed. So this gives you an ability to undo, just an unlimited number of commands back in time, or redo them as well. Let's look at how that command processor works in action. I'm going to be using a sequence diagram to kind of show you that timeline of how this actually all fits together. So here, for example, I have a view model, here's my command processor, and here's just a sample command called add patient command, okay? So the user clicks on a button requesting to add a patient. That view is going to be bound and send the add patient command to the view model. The view model is going to go ahead and call the command processor's process method, sending it an add patient command. And so that processor then is going to call the do operation on the command that we're going to see later where we actually define this do operation. But for now, just assume that the add patient command has a do method. So it's going to execute that command in this particular separate object, separate class. It's going to return to the command processor, and then before it's done, the command processor is going to take that command that it processed and actually save it in the undo stack. Then it's going to come back to the view model. View model is going to come back to the view. Later on, the user may want to undo this add patient operation. When this undo happens, the view is going to send an undo command to the view model. The view model is going to take the command processor and call its undo operation. Now the command processor is going to take that command that it saved in the undo stack and call that command's undo operation. Now the command's going to undo whatever it needed to do to add that patient, and then return all the way back to the view. So this kind of gives you an overview of what's going on internally with the command processor pattern. Let's look at what the command interface actually looks like. And I'm calling it the I undo redo command. It has these four methods. Can do returns true and false, just to tell the command processor whether it can even do the operation. There are some cases where you might not be able to do the operation. It also has a do method, an undo method, and a redo method. Okay, and we'll see how we use those in a little bit. Here's an example of the add patient command. It's going to implement this I undo redo command. In the constructor is going to take the model, the main model that we're dealing with. Here I'm just saying that it's always, you can always do this method. There's no reason why you cannot always add a patient, but you can imagine having perhaps some logic here that, if you have more than 50 patients, you can't do it, for example. Here in my do method, I create a new patient model. I save it internally because I'm going to need that later. And then I add it to my patients list in my model. Okay, so notice here that I'm not dealing with the view model or with the view or anything. I'm only dealing with the model. This is all model related, but because I have this system of notification, when this happens, the view model is going to automatically create a view model for itself, and then the view is going to also update its view and add a new patient to the view. In my undo operation, I simply remove that patient that I added, and for my redo, I add that patient back. So this is a pretty straightforward implementation. Again, the important thing is that your command implements the I undo redo command. Not only that, but every single operation in your script should implement I undo redo command. So any operation that you want to be undoable. Let's look at what the view model looks like as it's using the command processor pattern. Okay, so here's the add patient command property that's bound to the view. When the view asks for this command, the view model is actually going to get the command processor instance. This is using the singleton pattern, so there's only a single command processor in the whole application. And you call process by creating the actual add patient command and passing in the main model. For the undo and redo command, you're calling the command processor's undo and redo operations. And this relay command helper object that I talked about, part of MVVM Lite, also has a second parameter that can be true or false depending on whether that operation is doable. So here I'm calling, can do or can redo. The reason this is nice is because if you can't do this operation in the view side, the button that performs the undo is actually going to be disabled if this returns false. So for example, let's say you have an empty undo stack, this is going to return false and your button's going to be grayed out. If there's something in the undo stack, then your button's going to be enabled again and you'll be able to actually use it. All right, and the command processor here, here's a implementation of it. So it's processing, it's taking in an undo redo command. And the main thing I want you to concentrate on here is this piece of code here, where you have, it's calling the do operation of the command, and then it's pushing that onto the undo stack. Here you have your undo method. So basically, if it can undo it, it takes the last command from the undo stack, it calls it undo, and then it pushes it into the redo stack, because when you undo something, you actually might want to be able to redo it. So it puts it in the redo stack. Similar thing with the redo implementation. Gets it from the redo, gets the last command from the redo, calls the redo operation, and then pushes it into the undo stack. So one thing I do want to mention here, this other part of the code, this is one nice thing about a command processor, that because you're processing all commands in a uniform way from the same method, you can actually do things like log when a command is actually executed. So here, right before I do it, the command, I have a logging method that I say processing, and then I get the command name. And after it's done, completed, I get the command name. Then I wrap this whole command into a try catch so that if anything fails while trying to do this command, I can say failed running the command. So because I have this try catch, when something fails in your command, your whole script is not going to crash. Only that command is just going to fail. You might want to show here something to the user about, this couldn't be completed and so on. But here I'm just logging that error operation. So a little more on the command pattern and why it's nice. I did mention that you can handle logging in a uniform way for all your commands, but you can also handle things like authorization. Perhaps there's certain commands that you don't want any user to execute. You can have some kind of authorization system within your command processor that allows certain users to execute or not execute a certain command. If you want to get a little fancy, you can add a get description method to each of your commands, in the command interface. This would be nice in terms of a presentation to your users, because you can imagine having an undo menu where instead of just saying undo and redo, you might want to say undo adding patient or redo add patient. So this description can be displayed in that UI to the user. You might also want to manage some commands that are not undoable. Certain operations should not be undone. So if you, let's say, create a new command interface that doesn't have an undo operation, you can also handle that within the command processor as well. And finally, this is one, what I think is a fault of WPF. I've noticed that not every operation from the view supports commands. So buttons support commands, radio buttons support commands, checkboxes support commands, but something like a text box, when the user types something, that doesn't actually send a command to the view. So to support commands, to be able to undo whatever the user types, you do want to go ahead and extend that WPF text box and add command support to that. All right, so then the last section here that I want to talk about, and we'll go through this pretty quickly, is third-party libraries and why those might be good to include in your scripts. So there's many third-party libraries for .NET that you can actually include in your scripts. Everything from creating PDF documents, plotting data, logging information, writing unit tests, helping you with create MVVM applications, as I've mentioned before, interacting with the database, reading or writing JSON format, or ESAPI Essentials, which is a class library that I wrote to help you write better ESAPI scripts. So all these different tools are available for you to use. You don't have to reinvent the wheel and do it yourself. You can actually use some of these packages. And the way you do that is with using something called NuGet. And NuGet is easily available right from Visual Studio. You can right click on a project, go to manage NuGet packages, and you'll get a screen that looks like this. From here, you can type in the package that you might be interested in. So in this case, I'm typing in MigraDoc, and we're going to see how that helps you create PDF documents. You select the package you're interested in, and you click install. This will install it into your project. It will reference the libraries that it needs to actually make this work. So let's look at an example of using this PDF Sharp MigraDoc library. If we look at the API for this library contains things like adding header and footers to your document, being able to change the page setup like margins and so on. You can add images, add tables, add charts, add paragraphs, different kinds of text. So this API lets you construct basically a document through code, very similar as if you were working, let's say, with a Word document, but you do it all through code. And then by using this library, you can render that into a PDF document. And here's an example of what that PDF document might look like. And this document actually, I have code for this on GitHub. If you go to my blog website and search for PDF, you'll be taken to a blog that I actually show the code of how to implement this exact PDF. So you can see how to add tables, how to add images, and change fonts and all that to your PDF document. So this is something we use a lot at Radformation for generating our reports. Another nice third-party library that I recommend is Oxyplot. This allows you to plot and show plots to your users. So it supports lots of different kinds of plots. Here I'm just showing 3 random examples of using a line series. I'm showing some DVH curves here, a pie series, and a heat map series. So here I'm showing some dose information for a specific slice. Yeah, so this is something that I also have blog articles on my website if you're interested on knowing how to use Oxyplot. And one final API I want to talk about is our own ClearCheck API. If you use ClearCheck, you may want to automate some steps. You might want to check out this ClearCheck API. With it, you can get information about global and patient templates. You can add or remove dose constraints. You can add or remove plan checks. You can add or remove structure checks. This is, again, taking things from a global template and adding or removing those into your patient templates. You can do this, again, via code with the API. And then importantly, at the end, you can actually generate an entire report as a CSV file, a JSON file, or even a PDF report. All right, so with that, I want to just kind of give you some overall take-home messages of this presentation. We've talked about, using a plugin runner so you can run your scripts directly from Visual Studio and easily debug them. You want to uniquely name your scripts and their dependencies so that you don't have some of these name clashes if you potentially have lots of different versions that might be used within an Eclipse session. And this happens a lot with products like Radformation where people are running lots of different things. I recommend not calling ESAPI directly unless you're writing a very, very simple script and you know that you're never going to need it to be used with DICOM or any other kind of test data. But otherwise, you might consider wanting to wrapping that into your own separate API. I recommend using the MVVM architecture to kind of separate those concerns into your view model and model that helps you organize your code. And recommend using the command processor if you're going to want to support undo, redo functionality, or if you want to do things like logging or authorization of your commands. And then finally, take advantage of third-party libraries, a lot of them that are available out there, so that you don't have to reinvent the wheel. And with that, I just want to point out that, you know, Radformation is always looking for people who are passionate about writing software and improving cancer care. So if you're interested, send us an email about jobs@radformation.com. And with that, I thank you. And if there's any questions, I think Tyler will read them out to me.
Hey, yeah, Carlos, I'm here, and thank you for that really great talk. I mean, you went from start to finish, just packing that with awesome content. So I think,
Yeah, thank you.
yeah, hopefully we got some people that were interested and able to catch that. And so actually, we wanted to launch a poll. So we do have a handful of questions, but I want to first launch a few polls and hopefully get everyone's take on the webinar. So how well did you understand the content of the presentation? Did you get any of it? Not at all? Maybe a little bit? Did you get most of it, or was none of it new? Maybe, and wasn't worth doing? So please, yeah, indicate how well you understood that.
Yeah, this will really help us in the future to kind of tailor our level of presentations for future webinars.
Great. Okay. I still see a couple answers coming in. It looks like it's kind of plateauing now, so I'm going to close the poll, but I'll share it with everyone here. So nice distribution here. Good to see that that there weren't, that the presentation didn't fly miles over in anyone's head. So
yeah, I'm happy to see that too.
Yeah, great. Okay, so then I've got a couple more questions here to ask you. What is your level of scripting? It gives us an idea too, if we do want to tailor this in the future, if we do want to have any future webinars on this topic, maybe we can do something similar or something different. All right. And close that poll and share with you. Okay, so most folks out there are beginners. So yeah, maybe in the future we could do something very bare bones and basic. Okay, let's see. So you said you're coding. We're all coders here. What languages do you code in? And this one you can select any that apply. Carlos, do you have all these? You're gonna select all these?
Almost all. I don't have a lot of experience with MATLAB. I've done a little bit of MATLAB, but definitely C#, C++, and Python. I think just the MATLAB, a lot of physicists have background in that, but I don't have a background in physics. So.
Okay, it looks like we kind of have some stabilization here in the poll, so I'm going to close that and share. So I'm not surprised by those answers given the talk and the content here. All right, and one last one. If part of the power of ESAPI is that we can kind of tailor our solutions to our clinics. So what kind of scripts are you most interested in building using ESAPI? Maybe you want to do dose constraints and plan checks, or figure something out for image analysis. Yeah, drop it in here, and you can definitely select more than one here as well. And if you do have any more questions, feel free to keep dropping them in. I see people adding more as we're going along. Thank you. Okay, I'll close this poll. Thanks for all the votes, guys. There you go. It seems like most people are trying to create some automation with the dose constraints and plan checks. Yep, I think that makes a lot of sense in the clinic. Okay, yeah, well, thanks again for all the poll entries. So, Carlos, I got some questions queued up for you here. So,
All right.
how do you use Visual Studio if Eclipse is in Citrix?
Um, yeah, that is potentially an issue. What I've done before is I've had Visual Studio actually installed in the Citrix system, and you can use that. It's not my preference just because it ends up being kind of slow. Sometimes you can't even have Visual Studio installed in Citrix. So the way I've worked typically is just having my own either a virtual machine with Eclipse installed, or maybe using the a test system that has Eclipse installed. Or I was lucky enough to be able to ask my IT department to actually install a full version of Eclipse on my work computer. Um, yeah, otherwise it's going to be difficult. The other issue I found with using it on Citrix is that many times clinics might prevent you from accessing the internet. So sometimes it's kind of difficult or even impossible to easily use NuGet packages because you can't download them because you don't have access to the internet. So I would say that's difficult, but as I mentioned in my talk, if you do use things like the TPS service interface that you write yourself, then you can at least work through your script, most of it, and just have that plugin part where you develop the actual specific service that uses Eclipse, so that you're not constantly having to do that and debug your script on that machine, but only like for, after working on it for a day, then you can test it on Eclipse, but otherwise you can work on it using your own interfaces.
Yeah, okay, thanks, Carlos. The next question is with C# interfaces, you sort of have a quote unquote contract. So everything the interface has as properties, you have to implement those in your script. Is that correct?
Yes. Yeah.
Great.
Yeah.
Okay.
So, with properties, and I do want to mention this, with properties, sometimes that could be easy because all you're doing is just copying whatever's in Eclipse and putting it in your property. Something like patient name and stuff, that's pretty easy. There are cases where it can be a little more complex because sometimes an Eclipse might have a method that does something, um, and you can't necessarily, you might have to like re-implement that specific method in your interface sometimes. Because let's say if it's doing some kind of complex calculation in Eclipse, you can just call the Eclipse method. But if you're getting data from DICOM, let's say, or from a test patient, DICOM files don't have that method, so you might have to implement it for certain implementations, like your DICOM implementation. You might have to like reinvent the wheel, or try to redo it how Eclipse would do it in those cases.
Mm-hmm. Okay. So next question is, with your plugin runner, are you running your code directly from Visual Studio?
So what happens is, so the plugin runner, when you start it from Visual Studio, your plugin runner code would actually load your script. So because it's loading it from there, you'll actually be able to step through your code if you want to put a breakpoint in your code, or if an exception happens in your code, you can actually see that in Visual Studio. So it's like running it directly from Visual Studio. With the plugin runner, you'll be able to do all that.
Okay. So for junior developers with programming experience coming from maybe other languages such as Python, what do you recommend as tools to master C# and the ESAPI API, and overall become a better ESAPI developer?
Yeah, good question. So for C#, actually, when I started, 7 years ago at Michigan Medicine, I didn't have a lot of C# experience, and one source that helped me a lot was a book called Pro C# by, I'm looking at the book right now, by Andrew Trolson. That's a really nice tutorial book because it kind of goes through all of C# and in a very, good pace. So I recommend that book, Pro C#. But also there's a lot of resources online on learning C#. And specifically for ESAPI, if you go to variantdeveloper.com, There's a PDF book on there talking about ESAPI. There are links to the GitHub page that has lots of sample code. You can also check out my website. On my blog, I do talk about many beginner topics about ESAPI, and I have that organized in terms of beginner, advanced, intermediate, I think. So you can like go to the beginner category and see what some of those topics are about. You can check out, the varying documentation on ESAPI to kind of get familiarized with the code there. But the one thing I recommend is just to start coding and start writing some scripts and kind of get your hands dirty with it, and you'll start seeing and understanding, how to actually use the API.
Awesome advice. Yeah, it's good to have it from you, right? You're well ahead. Okay, I got a question about the ClearCheck API. Does the ClearCheck API open the ability to do the checks on multiple patients all at once, or is it methods that are available to the current patient that's being reported?
Yeah, I'm not super familiar with the ClearCheck API itself, but you can, because you're scripting it, you can call more than one patient and use it that way. If I remember right, in the sample code, actually, you can. What happens is you create an Eclipse application, and with that Eclipse application, you can open that patient and send that to the ClearCalc API, ClearCheck API. So if I'm not mistaken, you should be able to close that patient and open the next patient, and then send that in to your ClearCheck API.
Okay. So I have a question. If you can discuss maybe how to attach a debugger to a running Eclipse plugin script, if that makes sense.
Yeah, so in Visual Studio, in the menu there, I think if you go to the debug menu, I believe it is, when you have Eclipse already running, let's say it's running on your Eclipse machine, like you have to have Eclipse installed and it's running the script, you can choose debug and then attach debugger. There's a menu option there, and then you'll be presented with a list of all these different applications. If you choose the Eclipse application, it'll attach the debugger to that script, and assuming that you have Visual Studio open and you have your code open, it kind of magically links the code with the script that's running. And so if you get an exception, for example, in your script, Visual Studio will actually go ahead and take you to that line of code where where that exception was thrown.
Okay. Okay, so then through ClearCheck, does it provide an interface for a user-defined script? So just to extract some plan data, but not actually change anything in the database?
Yeah, so basically you're writing your own script. You have the freedom to do whatever you want with that script. It's just that you can optionally call the ClearCheck API to do these automatic operations of adding or removing checks from the global template to the patient template. But you're not restricted to only doing that. You can do, you have the full freedom of C#, so you can do whatever you want, either before or after, or even as you're processing these checks.
Cool. Yeah, so just a couple more questions that have been coming in. Thanks for all the interest, y'all. One question is, where can I find the documentation on the ClearCheck API?
Let's see, the link is pretty long.
Yeah, we can follow up with that one,
Yeah.
Mauricio.
Yeah, we
So
can go ahead and send a link. It's on our website, but we can go ahead and send a link to everyone so you guys can check the ClearCheck API.
Sounds good. Yeah, we can include that in the follow-up email. No problem. And then the last question before we all finish up, is it possible to create a plugin script that can be run side by side with Eclipse so that one can modify data in Eclipse locally and at the same time use the already active script?
If I understand that correctly, I don't think that's possible, just because when, well, let's see if I understood that correctly. I guess what they're saying is if you have a script running, whether you can modify the data somewhere else and then have it refresh on the plugin script. I found that you can't do that with plugins, because what happens is when Eclipse starts a plugin, it kind of locks all that patient data. in there. And so your script, while it's running, it's basically using whatever data happened to be given to it at the time that you started your script. So no, you can't really do that. However, you can do it with a standalone. If you have a standalone application, and let's say you open up you're running your script that way as a standalone, you can open a patient, have it display whatever information is about that patient or plan. You can open up Eclipse side by side. You can make changes, save those changes. Then if you go back to your standalone, you can implement, let's say, like a little refresh button. And that refresh button, what you want to do is you want to close the patient and then reopen the patient. And that's going to refresh all that new information. But in a plugin, I don't believe you can, because it kind of locks all that data when you started that script.
Mhm. Yeah, great, Carlos. That's the end of the question set. I'll take this opportunity to thank you, and then remind everyone that if you are here for credits, or if you're interested in getting credits for your participation here today, just make sure to jump into the handout section and open that PDF for a clickable link to the credits. And that's it. So thanks again, Carlos.
Awesome, and thank you everybody for attending. Hope everybody got something out of it. So thank you, Tyler, for taking all the questions.
Great. Okay, see everyone later.
Goodbye.